Good afternoon, sir.
Yeah. So 2:31. So we'll wait for 2 more minutes and we'll start the class. Okay, the 2 minutes over and we'll get into the class and I hope the screen is visible, right?
Yes, sir.
Yeah. So, okay. So where we are and what we are going to discuss for today's class, for especially for this session. Okay. So I will, for a better understanding, I can share the syllabus also. You can see the syllabus? No, right?
Yes, it's visible.
Yeah. Wait. I will share the entire screen and I can come back to this. Okay. So now I will come to the syllabus. The morning class we discuss how we supposed to write or convert the regular expression to finite automata. Okay, I explained with the two example and also initially I converted all the regular expression to epsilon NFA. That time I have shown many example. So I request all of you please take those regular expression and there we stop till epsilon NFA conversion alone. See who is that? Okay, so there we explain only the regular expression to epsilon NFA alone and for all the problem, right? So what I try to say here, for regular expression to DFA, only two problem we discuss. And whatever the problem I have discussed for regular expression to epsilon NFA, please convert all the regular expression to till DFA, whatever the way we did for the morning two examples. I mean, morning one example we did and the last class we did one example. Now we can think about the complexity. Taking one example will take one complete class. So with that, I have explained only two examples that itself took two classes. Anyhow, it is fine, but the understanding is very important. So parallelly, I need your cooperation also. Okay. So this is what the discussion we did as of now. Next, we have to see the reverse. Okay. Having given finite automata, we have to construct the regular expression now. Okay. So that is the discussion for today's class. Okay, so I will come to this finite automata to regular expression. What is that meaning? First, you have to recollect what is regular expression. Regular expression is nothing but the language. Generally, we know that any given language, we can able to design the machine, and the string of the language, we have to test it. By the way, the language can be represented in the shorter notation. That is what we know that regular expression. So designing the machine for the regular expression is nothing but designing the machine for the language. But as you can see, the regular expression will applicable only for the regular language, not for other languages. So now the machine, the construction or conversion, everything we did as of now. Now we are going to do the reverse. Having given machine, we have to construct regular expression. So that is the portion for this component, converting any finite automata to regular expression. Okay, so that we will see for today's class. First, you look at this diagram. From the diagram itself, you can find actually what diagram it is. They have mentioned only finite automata. They are not mentioning it is a DFA or NFA, nothing. They mentioned finite automata. It may be a DFA or it may be NFA. Now the question is, we have to convert the corresponding regular expression. That's all. Okay. Now we can look at this. For a Q0, we have a AB transition. Q1, we have a AB transition. Q2, we have a AB transition. So this is a DFA diagram. Now I wanted to find what is the language of this particular finite automata. So what are all the input actually this finite automata will accept? Say for example, L. Minimum the L will accept from the starting state one time of B. Minimum the next the machine will accept one time of A, one time of B. After B, if we have any number of A, go to Q2. I mean, after B, we have a A, it will go to non-final state. After single B, if we have another B, go to non-final state. After B, if we have a 2 times of A, non-final state. After B, if we have a 2 times of B, non-final state. After B, if we have a followed by B, non-final state. After B, B followed by A, non-final state. So these components are not at all belongs to this particular language. The language will accept B, the language will accept AB, or the language will accept 2 times of A, 1 time of B. The language will accept 3 times of A, 1 time of B. So it will go like this. It means what? Any number of A. So here the A is not available, right? And 1 time of A available, 2 time of, 3 time of. If it is not available, and any number of time it will be available. So this is literally the meaning of A star. And always the A star will ended with what? Single time of B. Now what is this and what is this? This is the language. This is the shorter notation of languages only. But the shorter notation I can call it as regular expression. So now what is the question? Having given finite automata, I have to design the regular expression. So here I have find the regular expression for this particular finite automata. Now you may ask one question. Sir, this is what the way we have to find the regular expression for all the given finite automata? The answer is no. This is a manual procedure. Always if you want to give some solution for any given problem or conversion, you have to give with the algorithmic procedure. By the way, even for the regular expression to finite automata also, we have a Thomson construction algorithm, we have a subset construction algorithm, and we have a state equivalence method for minimization. So each and everything should be given with the proper procedure and structure to the computer. So the same way, if you are converting any finite automata to regular expression, we have a dedicated method and procedure to do that. Okay, and other way, This is the way you have to explore and you have to identify. What is the shortcut method? Say, for example, if you are in this state, if you are looking at A, then the A in the self loop, always anything will be in the self loop. I can simply put it in star. After that, I can see B, the two one-way transition. Then I can add that B as the concatenation. Then after B, I don't find any other final state, so I stopped here itself, and I can say that this is the regular expression for this finite automata. Okay, so now this is the manual method, or with the knowledge whatever we have, we found that, but it is not the procedure always to handle all the problem. We need some name or a standard procedure to do that. Okay, so first I will come to the another example. Look at this example, and we can apply our general knowledge to find the regular expression. From Q naught, it will accept A followed by B. A followed by B. Minimum acceptance. A followed by B followed by A also accepted. A followed by B followed by B also accepted. Okay, and A followed by B, two times of A accepted. A followed by B, two times of B accepted. A followed by B, AB combination accepted. A followed by B, BA combination is accepted. So after AB, any combination of AB is accepted. Okay, starting with the B, non-final state. After A, another A, non-final state. After that, again AB, non-final state. Then what is the diagram is this? First, we have to identify. For a state, we have a two transition of two different input symbol. The two different input symbol, two different input symbol, two different input symbol. There is no any two transition for the same symbol. There is no any explicit lambda representation. So this is purely the DFA. Now for this given DFA, I wanted to find the regular expression. So again, I'll tell you that we don't have any, we have a method, but direct method, I will do like this. So what is the interpretation with respect to this language? Definitely the AB must be there for all the string. So for a regular expression conversion, definitely the AB should be a one important component, followed by either sometime I have A, sometime I have a B, sometime I have a both the combination. So if I put only A or B, then I will get only A or B. If I get any combination, then I will always put closure. So the corresponding regular expression for this particular DFA is AB, ARB whole star. So this is the thing which I have explored by create the string of the language and understand the strings of the language, then I have designed it. Is there any direct way by looking at the machine itself I can generate? Yes, as like I did for here. Simply from Q naught, there is a compulsory A, okay. After A, there is a compulsory B, okay. And here the A and B will be in the self loop, means definitely it is the star. Here I put comma, it means the comma is nothing but union operation. Either it may be written like A or B or A plus B, all will means that union operation. So I can put A or B. So here I have a concatenation, here I have a union, here I have a closure. So these three are the component of regular expression. Now I have generated the regular expression for the given DFA. Okay, so this is what the objective for this discussion. But this is what the way generally I wanted to proceed this. The answer is no. I wanted to proceed this with some algorithm. By the way, for a finite automata to regular expression, there are three algorithms are there. The first method is a state elimination method, and the another method is applying the Arden-Trey theorem, and we have a one more method that is That is the expression of complex in-text method, like Rij of I comma j, like that one method is there. But if I wanted to explain all the method, then your syllabus supposed to specify that method also. They are simply specifying that expression itself, then it is not mandatory to know all the method. By the way, I can remove this the complex method as well as the Arden theorem. I can simply go with the method of state elimination method alone. Okay. If time permit in future, if we have a time, then definitely I will tell you the procedure to do the same process in the Arden theorem also. But currently, for this conversion, we have to learn one method is enough. With that, I am explaining the state elimination method. Okay. So now I will tell you how generally the state elimination method will work. For that, the state elimination method will have one formula, and how the formula is derived from that point itself I can start discussing. So the state elimination method is also called as a generalization method. The state elimination method is also called as a generalization method. If you look at your first textbook, here, if you took a look at this first textbook, Woolman, there you can see the Arden's method as well as the state elimination method. That is a generalization method. But if you look at that Peter Lind's, you can see that the conversion of automata, I mean finite automata to regular expression, available only in the form of state elimination method alone. That is a reason for commonly I pick this state elimination method. That is a generalization method for this conversion. Okay. So we will see how first the formula will arrive, then I will explain to apply the formula to the problem, and we will explore it. So first you have to understand the formula for performing or writing the final regular expression is this pattern: R plus S U star T whole star S U star. That is the formula. So how the formula is arrived, so that explanation is available here. So if you are given with any finite automata, you have to eliminate all the state except starting and final state. Okay, you have to eliminate all the state except starting and final state. You have to leave only the starting and final state, and the other state you have to eliminate. First point. Okay. And what is the procedure we have to eliminate? If you are eliminating, what we supposed to do? These are all very important. I will tell you. Next, once you have to eliminate all the states in the given finite automata, and you have to form the structure like this: only the starting state and only the final state. So once you form the structure like this, once you can form the structure like this, once you can form the structure like this, starting state and final state, then there is a transition in the starting state itself, in the self loop, are called as R. There is a transition from starting state to final state, are all called as S. There is a transition from final state to starting state, I can call it as a T. There is a self loop transition in the final state, I can call it as a U. So this is what the component of R, S, U and T. So with that, how this formula is arrived? So this is the formula for writing the final regular expression from the given automata. So this is the expected transition for this particular topic. So how we supposed to do? How we can supposed to write? By the way, whenever if you are writing the language for this, okay, so the language may contain any number of R, okay, ended with S U star. I mean any number of R ended with S, any number of U star. Okay, so that is a one portion. Okay, the other component is otherwise. If it will not follow from the state with the R, it will follow one time of S, any number of U, one time of T. So one time of S, any number of U, one time of T. But always again ended with what? SU star. If you want to end, always it will go to SU star. Then what is the understanding? From the state, if I am following this, This is the pattern. From the state, if I am following this, this is the pattern. With respect to the pattern, the SU star is common for both, right? I will take it out. So what will repeat? What will repeat? Either the R will repeat or followed by SU star will done. Otherwise, so that's why I put plus symbol. Otherwise, SU star T will repeat. SU star, SU star T, SU star T will repeat. So for both, we have an option. Either the R will repeat any number of time or SU star T will repeat any number of time. But always ended with SU star only. So this is the final formula for this particular regular expression. So we need to form this structure from the given input. Then we have to write the regular expression in this format. Okay. So now you may ask other question. Okay, sir. If the finite automata will look like this, we can directly apply the formula and we will get the result. But as you said, the finite automata is also contains starting state, intermediate state, as well as final state. So how to handle that? Very simple. For that, the explanation of this one. Okay, so you have to simply eliminate all the intermediate state. So now the question, if you are eliminating, then what will happen? Okay, so first you can come to this common structure. We have a lot of starting state, we have a lot of ending state, and this is the state I can call as the state which you are going to eliminate. Okay, so if this is a situation, then from the starting state to the state you are going to eliminate, there is one transition, right? The transition will have some symbol, right? That symbol I can call it as Q1. See, this is again for our own notation. Okay, you can write A, B, C, D, X, Y, Z, anything it may be. But the transition of this is Q1. Next, from the state or the state we are going to eliminate, from the state to the next state, you have a transition. The transition is called as a P1. Next, the state you are going to eliminate, the state may have a self loop. That state transition in the self loop are called as S. Next, the state you are going to start, the state you are going to end, if between the state, if you have any transition, then you can write the transition as you can have a number, right? Q1, P1 or 1, 1. Taking this one from here, taking this one from here. So now, if you are eliminated this S, and if you are directly connecting this Q1 and P1, what is the option you have? You have a two option. One option is writing this R11 directly. Otherwise, you have other option is this one. What is the option? Q1, any number of S star P1. So if you add this also along with this, then you can eliminate this state. So that is the meaning, or this is what the way we are eliminating the state and rewriting the transitions or rewriting the symbols in the transitions. So previously the Q1 to P1 is R11 alone. If I am eliminating this S, then this has to be added with this pattern Q1 S star P1. So what about transition from here to here? Same scenario. Q1 to PM, we have already R1M. So R1M. Next, if you are eliminating this S, then from here to here we have a Q1, self loop we have a S. From here to here we have a, see, the number is this, this number based on this, and this number based on this. So here if you are writing the eliminating state to the end state, you have to write the number or the label as this particular label M. So what would be the result? From Q1 to PM, we have a R1M plus Q1 S star PM. That's all. Now we can eliminate this. What about between these? We have a Q R K1 will be there. With that, you can eliminate. You can add a QK S star P1. QK S star P1. Now, what between these two? We already have a K and M. So with the RKM, you can add QK S star PM. That's all. So now the state is eliminated. This is the rewrite state. Now after eliminating the state, you can find these two are only starting and final. Then you can apply this formula. So totally for the state elimination method to convert the finite automata to regular expression, we have a two formula. One is eliminating the state, you have to follow this procedure, and converting that state into this format, and you have to apply this formula. That's all. Okay. So now this is the explanation about how that formula actually arrived. Okay. So now you no need to remember or no need to by heart. If you know the procedure, then it will be easy for you. So now what I'm going to tell you, instead of going with a much theoretical discussion, I will take a problem and solve it. And I will tell you what is the result. Okay, so what is the result? Someone can tell me directly what is the regular expression for this? Okay, first tell me this is the finite automata of DFA or NFA.
DFA.
DFA. How did you say?
No epsilons.
Very good, no epsilon. But you see from A, transition of 1, we have a self loop as well as B. And here D are also one of the state, but there is no transition of 0 and 1 for D. Then how come it will become as a DFA?
Yes, sir.
So NFA, right? So what
Yeah.
is the regular expression? I don't know, but I'm generally writing. We have a self loop. 0 plus 1 whole star. We have a concatenation 1. We have a R option of 0 or 1. So 0 or 1. So this is the one's transition I can see with respect to starting state to final state. Now we have a one more final state also. So C is also final state, D is also final state. Again, I'll coming from the top. 0 plus 1 whole star 1. Here I have a 0 1, and here also I have a 0 1. So this is, I may be expected that see why I have added O plus, it means there may be a chance of this structure or there may be a chance of this structure. So we have an option. That's why I added a plus. I expected this is the final result of regular expression for the given finite automata. But I don't know. But we have to do it as per the formula we have. Okay. So first I will figure it out what I wanted to do. The structure as per the state elimination method is starting state and final state. By the way, here I have a two structure. One is A and C, another one is the A and D. For A and C, I want to remove B and I want to remove D. For A and D, I want to remove B as well as I want to remove C. Okay, so this is the two steps I have. Okay, so for two scenario. So first I can take a scenario number 1. That is, I wanted to form A to C alone. So I wanted to remove B and D, right? So we will see how to remove. So first I will look at this picture. Whenever if the state available as the middle state, then only we have a procedure, formula, everything. Whenever if you are going to do something with this state, after the state you have something, then we cannot apply this formula, right? Because if you consider this is a starting state, this is a state you are going to eliminate, then what about the end state? There is no any end state, right? Because if you apply the procedure, there should be end state. Then what I try to say from the picture, in that moment, you can eliminate this link just like that, and you can keep the remaining thing as the result. So for try to maintain this structure, first structure, I have eliminated D. I have eliminated D, and the remaining thing I can get from the picture is for A, I will have the input of 0, 1, and it will go to B with the input of 1, and we'll go to C with the input of 0, 1. So that's all for the first step. So I have removed D. So if I have removed D, nothing will happen because the D is available next to C. By the way, next to D, I don't have any other procedure or any other node, so I cannot apply the formula. I can simply remove. Now I'm going to remove B. Okay, so now remove B. So if I wanted to remove B, what will happen? I wanted to confirm. Okay, so you have to remember this. If you want to remove B, then B is the position of S. So if you remove this, then you have to write this structure, right? So first you have to explore the values. What is R11? What is Q1? What is S? What is P1 for this picture? Okay. So now what is R11? That is the transition from A to C. That is R11, right? Starting state to ending state, R11. So I don't have any R11. So the result is pi plus, what is the next one? Q1 S star P1. So I can write the formula also first time. I wanted to write R11. I wanted to know Q1 S star P1. So now the R11 is pi. There is no direct transition. What is Q1? Starting state to eliminating state. So the Q1 is 1. And what is the self loop of the eliminating state? Nothing. And what is the result of eliminating state to the final state? 0, 1. So the P1 is 0, 1. So now the R11 is pi. The Q1 is what? 1. Okay. And what is a S star? Pi star. And what is the P1? 0 plus 1. So I will tell you, comma 1, it means plus 1, comma 1 can be written as like the vertical bar also. Okay. So now what is the result? So the pi we have plus, what is the pi star? That's why here I have added some few formulas to recollect to handle the situation. Okay, so this is the pi symbol, right? So I have used this symbol for a pi. Whenever if you are added a pi with any regular expression, you will get the regular expression as the result. But the same way, if you are multiplying the pi with any regular expression, the result is pi. The reverse, if you are adding the epsilon or multiplying the epsilon with any regular expression or any regular expression with the epsilon, you will get the regular expression. That is what the way the multiplication operation will differ from pi and regular expression. Pi and epsilon, or epsilon are also called as lambda. Okay, so what is epsilon star? Epsilon star is epsilon. It means whenever you have a epsilon, you are finding the closure, the result is epsilon. The same way you can see pi. What is a pi star? The pi star is also epsilon. The pi star also epsilon. Okay, so the remaining thing you generally know from the discrete mathematics. So for this moment only, I just bring this scenario to the picture. Now you can see that here we have a epsilon. Pi star is epsilon. 1, 0 plus 1. Now, if you are multiplying anything with the epsilon with any regular expression, the result is the regular expression itself. So we have a plus 1, 0 plus 1. Now, just now we have seen if you are adding the pi with any regular expression, the regular expression itself is the result. So 1 into 0 plus 1. Then what is that meaning? If you are removing this b from the picture, instead of b, you have to write 1 into 0 plus 1 between a and c. That is the meaning. Okay. So now the next step, what I will write for the a, I have 0, 1 as such, no problem. But I have removed b, right? So I will directly connect it to c. So if we connect it to c, if you are removing b, then what you supposed to write in this transition? That is what I have computed here. So If you are removing B, you have to write 1 into 0 plus 1 from A and C. So I have write 1 into 0 plus 1 between A and C. Okay, so now as per the scenario 1, if I am considering A as a starting state, C as a resulting state, I found the situation or I constructed the situation. Then what I have to do next, I can simply apply the regular expression formula. So what is the structure of the regular expression? Structure of the regular expression is starting state, final state, there is a self loop, there is a transition from starting to final, final to starting, self loop of the final. So what is this? This is the, you can confirm that. Okay. This is S, the transition from this to this S, and this is R, this is T, this is U. So how to write? Whether it may be R or S U star T repetition. Yes, U star T repetition. But always ended with S U star. So now what is the understanding? The same scenario as we did for this picture, as you have explored the value of R11, Q1, S1, P1, here also you have to extract the value of R, the value of S, the value of T, the value of U from this diagram. Then